Yeah, this is lecture 7 of solubility equilibria. In the last class, I just introduced the application of solubility equilibria in qualitative analysis of basic radicals. Okay, and we understood that why group 1 metal ions get precipitated as chlorides, okay, while adding dilute HCl, and why not other metal ions are not precipitating, and in group 2 why ions like copper, cadmium, mercuric ions, right, these ions get precipitated as sulfide. Okay, why not group 4 metal ions are not get precipitated here? See, this is a very important question, keep this in mind, right? See, group 4 metal ions also get precipitated as sulfides. See, group 4 metal ions like, see, nickel 2 plus, zinc 2 plus, manganese 2 plus, right, etc. Group 4 metal ions, right, are precipitated as their sulfides. See, nickel as nickel sulfide, zinc as zinc sulfide, manganese as manganese sulfide, etc. Okay, but the question is, why not these metal ions are not precipitated, are not form sulfides, okay, as precipitate. Sulfides as precipitate in group 2 analysis. In group 2, what is the reason? Okay, I have told you the solubility product values of these sulfides. Okay, solubility product of sulfides of nickel sulfide, zinc sulfide, manganese sulfide, etc. If you compare with the solubility product of group 2 metal sulfide like cadmium sulfide, copper sulfide, okay, mercuric sulfide, etc. If you compare these two, observe carefully, the solubility product values of these sulfides are extremely high. They are extremely high, they are very high. Okay, or I can say the other way, the solubility product values of these sulfides are very, very low. So, the concentration of sulfide ion in group 2 analysis, you know very well. In group 2, we'll take salt solution, we'll add dilute HCl, then we'll pass H2S. Okay, see, in the presence of HCl, if you pass H2S, the concentration of sulfide ion, right, in the solution will be very, very low. It's extremely low. It's extremely low. Okay, therefore, the concentration is insufficient to precipitate these sulfides, whereas this is sufficient to precipitate the sulfides of group 2, because the solubility product values of the sulfides of the group 2 are very, very low. Okay, we discussed in the last class. Right, now let me continue this to the group 3 metal ions. Okay. Right, see, before going to group 3, what we do in group 2, listen, if there is no group 2 metal ions present, you will never get any precipitate, but the salt solution, to the salt solution we have added dilute HCl, we have added H2S, correct? So what we have to do? We have to remove this. How? Just boil up the solution. Just boil the solution. If we boil it, H2S will go away. Okay, and we have salt solution and very low concentration of HCl may be there. Right? But in group 2, what we add is that to this solution, salt solution and very low concentration of HCl, let us assume that HCl is not there, because while boiling of the solution, right, HCl also, right, will go out. Okay, therefore some small amount will be there. Okay, you need not consider that. Take the salt solution, to this add ammonium chloride and ammonium hydroxide. Okay, I have told you ammonium hydroxide is a weak base which undergo partial ionization and produce hydroxide ion. In the presence of ammonium chloride, which contain common ion NH4 plus ion, due to the presence of common ion, the dissociation of ammonium hydroxide is suppressed. So here, the concentration of hydroxide ion in the presence of ammonium chloride is very low, is extremely low. Is very low. Since the hydroxide ion concentration is very low, only these metal ions get precipitated as their hydroxides. Which are the metal ions? See, aluminium ion Al3 plus, ferrous ion Fe2 plus, ferric ion Fe3 plus, etc. Only these metal ions get precipitated. Why? I'll give the solubility product values of these hydroxides. For aluminium hydroxide, the solubility product value is 4.6 into 10 to the power minus 37. See, I am giving you the values of solubility product at 25 degrees Celsius. And all these values are taken from standard books, so you need not worry about that. Aluminum hydroxide 4.6 into 10 to the power minus 37. And ferrous hydroxide, the value is 8 into 10 to the power minus 16. And for ferric hydroxide, the value is 2.5 into 10 to the power minus 39. See, the values are very, very low. Okay, since the values are very low, these metal ions are get precipitated as their hydroxides. Okay, in group 3. Right? See, here a question arises. Listen, why not zinc? See, for zinc hydroxide, zinc also can form zinc hydroxide. Okay, but magnesium can also form magnesium hydroxide. Okay, nickel can form nickel hydroxide. Suppose if group 2 metal ions or the other group metal ions, for group 4, group 5, right? If other group metal ions, right, are present, they can also form hydroxides. Okay, when we add this reagent, ammonium chloride and ammonium hydroxide in salt solution, if group 4 metal ions are present, these metal ions can also form hydroxides, but they never get precipitated. Why? See, for zinc hydroxide, the solubility product value is 2.1 into 10 to the power minus 16. Okay, and for magnesium hydroxide, the value is, this is actually 10 to the power minus 14. I'm sorry. And for magnesium hydroxide, the value is 1.8 into 10 to the power minus 11. And for nickel hydroxide, the value is 2 into 10 to the power minus 15. Okay, see the values. The values are quite high compared to this. Okay, so these metal ions, their hydroxides, for which Ksp value is very high. Solubility product value for these hydroxides are, for these hydroxides, solubility product value is very, very low. Whereas the hydroxides of other metal ions, other group metal ions, group 4, group 5, group 6, right, for which their hydroxides have high solubility product, which means since their solubility product is extremely low, even small concentration, very low concentration of hydroxide ion is sufficient to precipitate, okay, these hydroxides, these metal ions as hydroxides. Okay, that's the reason why in group 3 we get precipitate of aluminium or ferrous or ferric. These ions get precipitated in group 3. Even group 4, group 5, group 6 ions are present here, they never form any precipitate. Why? The concentration of hydroxide ion is insufficient. Okay, it's insufficient to precipitate the group 4, group 5 or group 6 metal ions. Okay, yeah, keep this information in mind. Now, let me move on to the group 4. See, in group 4, what we do is that, listen, see, in group 3 we have already added salt to the salt solution. We have added ammonium chloride plus ammonium hydroxide. We have already added this. So, the solution is basic. The solution is basic. Now, in group 4, what we do is that we pass H2S gas, okay, in presence of these these compounds. See, we have salt solution, we have ammonium chloride, we have ammonium hydroxide, right? Then we pass H2S gas through that. Okay, the concentrations are very low, but we pass H2S in basic medium. This is basic. Okay, in basic medium, H2S undergoes ionization in larger extent. Why? See, H2S dissociate to give 2H plus ion and S2 minus ion. This dissociation occurs. In basic medium, okay, the base will consume this H plus. Therefore, more H2S starts to dissociate. Therefore, sulfide ion concentration, okay, in this stage, in basic medium is extremely high compared to the sulfide ion concentration in acidic medium. In group 2, we pass H2S in acid medium. So, sulfide ion concentration in group 2 is very, very low. Whereas in group 4 analysis, we are passing H2S gas in basic medium. Concentration of sulfide ion in basic medium is so high. Therefore, it can precipitate, okay, the sulfides of these metals like nickel sulfide, zinc sulfide, okay, manganese sulfide, etc. Why? Because their solubility product values are very, very low. Okay, somewhat low, but compared to group 2 metal ions, the values are high, but compared to group 5 sulfides, okay, they are very, very low, right? So that's why these sulfides get precipitated in group 4. So what's the reason? The reason is that in basic medium, sulfide ion concentration is high. This is sufficient, this concentration is sufficient to precipitate the group 4 metal ions like nickel, nickel 2 plus, zinc 2 plus, manganese 2 plus, etc. Okay. Here you may ask the question, so why not group 5 metal ions? Why not group 5 metal ions like calcium, strontium, barium, right? Okay, why not these metal ions get precipitated as their sulfides while doing group 4 analysis? Why not these metal ions get precipitated as sulfides while doing group 4 analysis? The reason is that the solubility product values of these sulfides, KSP of sulfides of calcium ion, barium ion, strontium ion, etc. is very high. It's very high. So these metal ions never form precipitate in group 4 stage. Okay. Okay. Now we'll move on to group 5. See, before going to see group 5, in group 4, to the salt solution, we have added ammonium chloride, ammonium hydroxide, which forms the basic medium, and H2S gas. Okay. Now what we have to do, before move on to group 5, we should remove H2S. So just boil up the solution, just boil it, that way H2S gas will come out. So your solution now contains salt solution plus ammonium chloride, okay, plus ammonium hydroxide. It remains as basic. Now in group 5, what we are going to do, to this mixture, salt solution, ammonium chloride, ammonium hydroxide, to this mixture, we should add ammonium carbonate, NH4 twice C3. If we add ammonium carbonate, what will happen? Listen, if we add ammonium carbonate, okay, the group 5 metal ions get precipitated as their carbonates. Okay, see what are the ions present in group 5? Calcium 2 plus, basically alkaline earth metal ions, right? Calcium, barium, strontium, etc. These ions are present in group 5. These metal ions are precipitated as their carbonates. Calcium get precipitated as calcium carbonate, barium as barium carbonate, strontium as strontium carbonate. Why? Because their solubility product values are very low. Okay, solubility product for calcium carbonate is 3.8 into 10 to the power minus 9, and solubility product value for barium carbonate, it is 2.0 into 10 to the power minus 8. Okay, and for strontium carbonate, the value is 9.3 into 10 to the power minus 10. See the values are very low. So for these low values of solubility product, these metal ions get precipitated as they are carbonates. Okay, whereas see, if you take magnesium ion, which is present in group 5, the magnesium carbonate, observe carefully, for magnesium carbonate solubility product value is 1.0 into 10 to the power minus 5. While doing group 5 analysis, magnesium never formed precipitate. Why? Because the solubility product value is comparatively high. Compared to this value is high. Therefore, the carbonate ion concentration is in same. See here also. See ammonium carbonate. Okay, ammonium carbonate. So we had a very low concentration of ammonium carbonate here. Very small amount. That small amount of ammonium carbonate gives very low concentration of carbonate ion. Carbonate ion concentration is very low. Very low. This concentration is insufficient to precipitate magnesium as magnesium carbonate, because solubility product of magnesium carbonate is quite high. Whereas for these metal ions, their solubility product values are very low. See this. Therefore, at group 5 stage, only these metal ions get precipitated as carbonate. Magnesium never form carbonate here. Okay, yes. So, this is the application of the ionic equilibria or solubility equilibria. This is the application of solubility equilibria in the qualitative analysis of basic radicals. Okay, yeah. I stop here.